Hello and welcome to Sean White's Solar and Energy Storage Podcast. This time we're going to talk about EV bidirectional charging in the National Electrical Code, that's the NEC, with Bill Brooks. The name of this NEC article is Article 625, Electric Vehicle Power Transfer System, and that's in the 2020 NEC, which changed from Electric Vehicle Charging System in the 2017 NEC. You can see that EVs, according to this change in the NEC, are not just for driving anymore. They are relatively big batteries that can also send power back to the grid or to your home. In Japan, Nissan has already been doing this for quite a while. After that big nuclear power plant went kaboom, people were without power for extended periods of time and were frustrated knowing that they had big batteries in their driveways and perhaps non-working interactive solar systems on the rooftops. The hardware was there for the most part, the need was there, so why was it not working? Perhaps it has to do with the warranties, which we will discuss in our next podcast. This time we are going to get deep into the code and talk about Article 625, Electric Vehicle Power Transfer System, which goes very well with the new 2020 NEC, Section 705.13, Power Control Systems. Article 705, by the way, is Interconnected Power Production Sources. We tie all of this together in our free online 2-hour class for NABCEP continuing education and prerequisite credit entitled Solar Building Codes, Fire Codes, EVs, Rapid Shutdown, and Energy Storage Systems, if you want to go there. And we even more thoroughly cover this in our advanced 40-hour and 30-hour classes at HeatSpring. You can get there by going to solarsean.com. That's solar, SEAN.com. Now, let's get to our talk. Here we got electric vehicle power transfer systems.
So this is electric vehicle chargers. For those of you who don't understand, see power transfer, that got changed.
I mean, you could go both ways.
They changed the terminology because they were getting ready for that. Because it said electric vehicle charging system in the earlier code, and that's why they changed it to power transfer. Because charging obviously is one direction. Power transfer could be either direction. So that's interesting that they made this. And they changed the scope to premises wiring for the purposes of charging, power export, or bidirectional current flow. So they added that to the scope, and that was not part of the scope in the 2017. So that's very interesting. Of course, we see some new information here on power export equipment, EVPE, supply equipment, and all fastened in place. So these are all definitions in the definition section.
There's not too many definitions in Article 625. So what I'm going to do is I'm going to read the definitions here. So if you are driving your electric vehicle down the freeway, you can listen to these different definitions. Definition number 1, electric vehicle power export equipment, EVPE. The equipment, including the outlet on the vehicle, that is used to provide electrical power at voltages greater than or equal to 30 volts AC or 60 volts DC to loads external to the vehicle, using the vehicle as the source of supply. Informational note: electric vehicle power export equipment and electric vehicle supply equipment are sometimes contained in one piece of equipment, sometimes referred to as bidirectional EVSE. And that brings us on to EVSE, which is Electric Vehicle Supply Equipment, EVSE. The conductors, including the ungrounded, grounded, and equipment grounding conductors, and the electric vehicle connectors, attachment plugs, personal protection system, and all other fittings, devices, power outlets, or apparatus installed specifically for the purpose of transferring energy between the premises wiring and the electric vehicle. Informational note: electric vehicle power export equipment and electric vehicle supply equipment are sometimes contained in one piece of equipment, sometimes referred to as bidirectional EVSE. We just said that in the previous definition. The two previous definitions were new, and so is this one. It is fastened in place. Mounting means of equipment in which the fastening means are specifically designed to permit periodic removal without the use of a tool for relocation, interchangeability, maintenance, or repair. Next definition, fixed in place. Mounting means of an EVSE attached to a wall or surface with fasteners that require a tool to be removed. Next definition, output cable to the electric vehicle. An assembly consisting of a length of flexible EV cable and electric vehicle connector, supplying power to the electric vehicle. Next definition, output cable to primary pad. A multi-conductor shielded cable assembly consisting of conductors to carry the high-frequency energy and any status signals between the charger, power converter, and the primary pad. Personal protection system. A system of personal protection devices and constructional features that, when used together, provide protection against electric shock of personnel. Portable, as applied to EVSE. A device intended for indoor or outdoor use that can be carried from charging location to charging location and is designed to be transported in the vehicle when not in use. Power supply cord, an assembly consisting of an attachment plug and length of flexible cord that connects equipment to a receptacle. Primary pad, a device external to the EV that transfers power via the contactless coupling as part of a wireless power transfer system. Wireless power transfer, WPT. The transfer of electrical energy from a power source to an electrical load via electric and magnetic fields or waves by a contactless inductive means between a primary and secondary device. And the last definition is wireless power transfer equipment. That's WPTE. Equipment consisting of a charger, power converter, and a primary pad. The two devices are either separate units or contained within one enclosure. That's it for Article 625, Definitions. And isn't it great that we have all of this wireless charging infrastructure in the code now? That means that we can be lazy. I also wonder what that means as far as those wavelengths going through the air. It's sort of like getting close to a transformer. Is that going to be good for you? Maybe that will be healthy. Maybe it won't be. And if those definitions weren't interesting enough, let's get really interesting now.
Where it gets really interesting is up here under overcurrent protection. So when we get up to overcurrent protection, we are talking about having sufficient rating. This is where we get into power control. So 625.42 is really what got us talking about power control systems for 705.13. And they've obviously made a bunch of changes here, but the language is power transfer equipment shall have sufficient ratings to supply the load served. Okay, great. Electric vehicle charging loads shall be considered continuous loads for the purposes of this article. Okay, great. They're big. Service and feeders shall be sized in accordance with the product ratings. Okay, well, that's important. Where an automatic load management system is used, the maximum equipment load on a service and feeder shall be the maximum load permitted by the automatic load management system. That is power control in reverse. It's load management. Okay, so what it's doing is it's a sequencer or whatever. And what they're saying here is that you could have, for instance, you could have 2,000 amps worth of electric vehicle chargers, and you could bring a 400 amp feeder to that 2,000 amps and feed that 2,000 amps worth of chargers, but the load management system is never going to allow the load to go over 400 amps. And that's a big deal, because if you had to size everything according to the first two sentences, worst case, full time, full on all the time, you'd have to run 2,000 amps to that, which most people wouldn't do. And so that's a really, really key point. And then they put a lot more information in here about adjustable settings, ratings, and things like that, which are very much relevant to our power control systems. So what this is saying, even in the 2017 code, even if people are on the 2017 code, they could employ a load management system. Based on this information, you could put a load management system on a house. Let's say you had a 100 amp service and you got 2 electric vehicles. This happens fairly common in the Bay Area. You know, people are wanting to go all electric or whatever, and they got a 100 amp service. And so what happens is you could have a load management system that could actually shut down your EVs if the load ever got above what the service could handle. And Article 220 couldn't have anything to say about that.
And just for those of you that don't have the whole NEC memorized yet, Article 220 is branch circuit, feeder, and service load calculations. And I'm just going to read the scope of Article 220. This article provides requirements for calculating branch circuit, feeder, and service loads. Part 1 provides general requirements for calculation methods. Part 2 provides calculation methods for branch circuit loads. Part 3 and 4 provide calculation methods for feeder and service loads. Part 5 provides calculation methods for farm loads, y'all. And once again, that was Article 220, branch circuit, feeder, and service load calculations. That's what Article 220 is all about, is load calcs.
Article 220, which may say, hey, electric vehicle charger there, you can't do this. This trumps Article 220 and says, well, you know what? If you've got a system, if it's capable of shutting the thing off, you don't add it to your load calcs. And that's a big, big deal. And that's where you're going to find it. So 62542 is the key section in there. That's really the one to look at, focus on.
Okay, Bill, whatever you say. So let's focus on that. That's 625.42, rating. The power transfer equipment shall have the sufficient rating to supply the load served. Electric vehicle charging loads shall be considered to be continuous loads for the purpose of this article. Service and feeder shall be sized in accordance with the product ratings. Where an automatic load management system is used, the maximum equipment load on a service and feeder shall be the maximum load permitted by the automatic load management system. And then this is new stuff here because it's highlighted. It says, adjustable settings shall be permitted on fixed in place equipment only. If adjustments have an impact on the rating label, those changes shall be in accordance with the manufacturer's instructions, and the adjusted rating shall appear with sufficient durability to withstand the environment involved on the rating label. Electric vehicle supply equipment with restricted access to an ampere adjusting means shall be permitted to have ampere ratings that are equal to the adjusted current setting. Sizing the service and feeder to match the adjusting means shall be permitted. Restricted access shall prevent the user from gaining access to the adjusting means. Restricted access shall be accomplished by at least one of the following. 1. A cover or door that requires the use of a tool to open. 2. Locked doors accessible only to qualified personnel. And 3. Password-protected commissioning software accessible only to qualified personnel. Yeah, you don't want to have an electric vehicle charging bank of all these electric car chargers and then have the guys charging their cars that don't know anything about electricity going out there and changing the settings on things, do you? You got to lock it up. Lock up your settings. And remember, as Bill was saying, 625.42 rating inspired 705.13, and that is new in the 2020 NEC, and that is called power control systems. And we go deep into that in our classes on HeatSpring. Okay, so now take a deep breath and listen to Bill talk about when your car needs to breathe. Doesn't need to breathe at your house, but we'll see what Bill has to say about that.
Now, vehicle ventilation required for electric vehicles. This is getting into facilities that are providing electric vehicle ventilation. This is not for your garage. Your garage, positive ventilation, all this kind of stuff, that's not something that you're going to employ in your garage. That's a little bit about power transfer equipment. And the good news is it's very encouraging to see that the folks that are covering that article are thinking ahead, because this is going to coincide very much with what we're doing in 705.13.
I am waiting to get an electric car that I can send electricity back to the grid or to even power my house with it. It's kind of silly that we can't do this already. The auto manufacturers and some people say, oh, it's because of the warranty of the battery. Well, give me a warranty for kilowatt hours instead of miles driven or years in time. In the meantime, let's study electric vehicle power transfer system. I don't know why they don't call it systems. Maybe they will in the 2023 NEC. Thanks for listening to Sean White's Solar and Energy Storage Podcast. You can find out more about Sean White's classes and everything else that he does at SolarSean, that's solar, SEAN.com. And also, please, I beg you, give me a whole bunch of stars on this podcast. I guess. I don't know. People say I should say that. So I said it. Okay. Lots of stars. Thanks a lot. Over and out.